Hello. I'm here live with First Hour. We're going to do the answer guide. This is a homework tutorial for 714 Part 2, problem 753 through 758. We'll get as many as we can done before the bell rings for First Hour, and then I'll probably just keep going. So let's jump right into question A. Rose, you really complaining about there's too few variables? These are one variable equations.
I'm
X, that's all there is. All we have to do is distributive property and not make a mistake, which is quite the tall order. There's still a lot of steps here. The first thing we got to do here is the distributive property, because the -7 is being multiplied times that, so we got to distribute first. So let's very, very carefully, hopefully if you learned anything in the last 8 months about how to properly tackle problems like this, take your time. Show steps, do not skip things. 3x is going to stay right where it is. This is now -28. This is now -14x. Which equals -x plus 2. The only thing I would change in this first step is the distribution of the -7. Next, let's combine the like terms on the left side. I see 3x, -14x. Let's make that -11x because we're adding them together. -11x minus 28 equals -x plus 2. Finally, we're at kind of the standard 3-step stage here. I like to try to keep things positive, so I'm going to add the 11x to both sides. Carefully make sure you're adding it underneath the x terms so you don't get confused about what combines and what doesn't. You got -28 equals 10x plus 2. Now we're going to subtract the 2 from both sides and get -30 equals 10x. And finally, we'll divide by 10 and get -3, which is suspiciously a whole number. Look at how much work I had to show to do that problem. Do not try to do this in your head. And do not be intimidated by it. It's just step by step. There's a lot of steps, but each step is simple. Since this is not intended to be an instructional thing, I'm going to the next question. Question B. Again, this one is relatively simple. It's only got one variable, x, and that's it. So we're going to combine some like terms first. -5x and -x can combine to -6x. And 2 plus 1 is 3, which equals 0. This one you might be able to tell me the answer just by staring at it for a minute. It's going to be 1/2. Half of -6 will be -3, plus 3 is 0. But it's okay if you want to do the rest of the problem. Subtract 3 from both sides, -6x equals -3. And we're going to divide by -6, and there's your positive 1/2. -3 divided by -6, 1/2. Schwabba-da-boop-bop-boo. Next question. What? You're welcome. 754. Jerry says, I got money in my grade account that compounds interest monthly. The equation y equals 388 times 1.008 to the nth represents how much money I have at the end of any month. What is his monthly interest rate? That's just asking what b is. It's 1. Well, that's not quite the answer to the question. The multiplier is 1.008, but just like that question on the quiz that threw some people for a loop, what's the percent growth that we're talking about here? That's the question. First of all, we're going to remove the 1 from the situation, because 1 just is a placeholder to make sure the original money is all there. So we're talking about 0.008. If you want to convert that to a percentage, you got to move the decimal 2 spots to the right, and you'll notice that we're not to 8 yet. That's because this is 0.8%. It's less than 1%. In case that seems small to you, remember he's getting that rate 12 times a year. This is monthly compounding, so he's getting a very small chunk of his interest 12 times a year. So his real interest rate for the year is 8 times 12, but that's not 7.2%. Unimportant for this question. And the second part is even easier. Write an equation to represent your total money if you invest $500 in an account with the same return. So instead of it being 388, it'd be 500 times 1.008 to the nth power. Things are often very obvious when you give it a chance. For the next question, we got some systems of equations. You'll notice the question A is the question from the quiz. Got him. We're going to solve this by substitution. So we're going to take the y equals x plus 10. We're going to plug it in for y in both of those y's up above. And it'll look something like this. 2x plus x plus 10. So much noise. Do you guys at home hear that noise? So much. Just chill. 7 times x plus 10. There you go. We got to plug in x plus 10 twice. This is the the thing. A lot of you guys already solved this question on the quiz correctly anyway, so it's not a big deal. Now, I did see a lot of mistakes on the left side, people trying to distribute here. That's not a multiplication sign. It's a plus sign. So you're just going to add on the left. 3x plus 10 is all the left needs. Now, on the right side, that's multiplication. So this is where you do need to distribute. Take your time, go slow, give yourself a chance to think about those things before you fall right into the steps that you think you got to do. Negative 7x plus 70 from there. And then from here, it's really straightforward. I will start by adding 7x to both sides and getting 10x plus 10 is equal to 70. Oh, that's, whoops. This is a plus 10. So it means that this is a minus 70. There's where my mistake was. That's a negative 70. And then when we subtract the 10 from both sides, negative 70 minus 10 is going to be 80, negative 80, and that's where x is negative 8. Again, I'm going fast in this question because it was already on the quiz. And now that you know that x is negative 8, that means that y is 2. And you can test that out in the top equation just to make sure it works. Next problem. Question, why is it A? It should be B. Oh, well. This one, again, it's kind of a head scratcher. You either use substitution or elimination. I don't know. That's kind of the theme with these systems of equations problems in the back half of Algebra 1 is, okay, now that we kind of have those two things mastered, what else can we do? In this case, I think I would recommend doing elimination. I don't see x or y by itself, which is usually an indication that you're going to use substitution. So, before we can use elimination, we got to move some things around. The numbers aren't stacked up correctly. Here's a good example. X is on the left side of the equation, in both equations, but y is not. Y is on the left side, down the bottom, it's on the right side over there. So if you're going to try to add these together right now, you're misunderstanding the value of y on both sides. So the first thing I'm going to do is I'm going to take the 5y, I'm going to add it to both sides in the top equation. Think about this like the algebra tiles that we did at the beginning of the year. I'm going to take negative 5y and flip it over to the other side. So my top equation is now going to be 3x plus 5y equals 0, because there's nothing left on that side anymore. The reason why I did that is because now 5y is vibing on the left side of the equation. And now I can do elimination because I got x's and y's together on one side. The second equation stays exactly the same. I'm not touching it. But before we can do elimination, nothing will eliminate right now. None of the coefficients are the same. We got 3x and 6x. We got 5y and negative 7y. But I do see 3 and 6. That's just got a little 1 to 2 relationship. So if we multiply the top equation by 2, we'll have what we need. We just got to remember to multiply everything by 2. So the top equation will now become 6x plus 10y equals 0. The bottom equation, again, stays exactly the same. And now we're ready to do elimination. So we'll subtract. Because 6x's are both positive, so we got to subtract so they cancel out. 10y minus negative 7y is a positive 17y, which equals negative 17. Careful on the subtraction there. That's 10 minus negative 7, which is positive 17, and 0 minus 17, which is negative 17. And then that means y is negative 1 if we divide by 17 on both sides. We're almost there, but we still have some work to do on this one. Let's take y, let's plug it into the top equation. Top equation is pretty simple. This will leave us with 3x equals negative 5 times negative 1, which means that 3x is equal to positive 5, which means x is whatever in the world 5 divided by 3 is. 1.6. No, 1.6 repeating. Doesn't matter.
Teachers, interruption. Here we go.
Oh boy. If you're watching this after the fact, please skip ahead 3 minutes. I'm gonna get a coffee.
Boys, Hunter Rope, Daniel Spence, Jack Stewart III, Blaine Barkovich, Connor Cameron. The girls, Olivia Scarborough, Emma Angerbrand, Sydney Shetler, Bailey Royce, and Lauren Judd. Congratulations to the prom court.
I'm always just rooting for a band kid. Always rooting for a band kid. I'm gonna keep going because this recording is gonna keep going, so I'm just gonna do some more problems. When you guys are dismissed, you're dismissed. If you put my calculators away, that'd be a great thing. Good. Calculators, please. All right. Hello. I'm just going to keep talking to this microphone right here. 756, find the equation line with x-intercept negative 4 is 0 and y-intercept is 0, 9. That's going to be pretty easy to do. First of all, they told us what the y-intercept was, so I know that b is going to be 9. in my equation. And it's a line, which they, again, told us, so I know it's going to be mx plus b. So b is 9, and that's already done right there. As far as the slope goes, all we got to do is figure out the change in y and the change in x, which is, again, relatively easy to do because they told us the 2 points that are on there. We have x and y, we have x and y. We have a 9 minus 0, and we have 0 minus negative 4. What's your second hour? Okay, I'll come to you. This is 9 over positive 4, which is 2.25, but I'm going to use 9/4 because I like the fraction a little better. So the equation of the line is going to be 9/4 times x plus 9. And there is the equation of the line. For 758, all we got to do is determine if the following equations are true for all values. In other words, always true. For those that are not, decide if they are true for certain values, which means sometimes true, or never, which is never true. So looking at A, for example, this is a classic thing. You saw this on the test, Chapter 3 and Chapter 5 test. This is not always true. However, here's a good way to think about this question. Let's pick a number for x. Like, how about if x is 3? 3 minus 5 squared might be equal to 3 squared plus 25. 3 minus 5 is negative 2. Negative 2 squared is 4. 3 squared is 9, and 9 plus 25 is 34. These are not the same thing. So the answer is not always. That doesn't mean it's not never. A good example is if x equals 0. If x equals 0, you get negative 5 squared equals 0 squared plus 25. And both these are 25. So the answer here is sometimes. Another good way to do this is to graph them on your calculator. Graph y1 and y2. And see if they cross. If they cross ever, then it's sometimes. If they never cross, it's never. And if they are the same graph, then it's always. Question B. A good way to handle this problem is to actually just multiply on the left and figure out what this is. 2x times x is 2x squared. 2x times 4 is 8x. Negative 1 times x is minus 1x. And negative 1 times 4 is minus 4. And look at this. This is 2x squared plus 7x minus 4. This is always. These are the same thing. Question C. Again, we're kind of dealing with exponent rules here for a minute. I suspect this is always. It is. The only exponent rule we really need to do is y to the third over y to the second power, which is where we're going to subtract those exponents. So 2 and x squared stay exactly the same, but y to the third minus y to the second is just y to the first, and that's it. This is another always. And finally, question D, we have 3x minus 2 times 2x plus 1. We're going to multiply this together and see if it's ever equal to what we have on the right. So 3x times 2x is 6x squared. 3x times 1 is 3x. Negative 2 times negative 2x is minus 4x, and negative 2 times negative 1 is minus 2. So we have 6x squared minus x minus 2. And the problem here is that the number being added at the end is a different number. I believe this is never. Because I don't think if you plug a number in for x, I don't think you're ever going to get the same number for, you'll always get the same number for 6x squared minus x, but you'll never get, after you subtract 2 or subtract 5, you'll never get the same number after that. Hey, thanks for watching this video. Don't forget, you guys are awesome, and I'll see you in the next one. Don't forget your charged Chromebook on Monday for the NWEA.